I'm going to work through the Seneca topic on quantitative chemistry, and I am looking at the relative formula mass section, which will appear on paper 1, chemistry paper 1 in your GCSE exam. So I'll click on start learning now. So first of all, there's a little bit of information for me about the law of the conservation of mass. And what the law of the conservation of mass tells us is that in a chemical reaction, the mass of the reactants, which are the things you put into the chemical reaction, that mass will be exactly the same as the mass of the products, and that's the things that you produce in the chemical reaction. Now, if you did this on a balance in a lab or something, you might notice a change in mass, because sometimes the product might be a gas. It might escape from your chemical reaction, but it's all still there. So the law of the conservation of mass says that no atoms can be created or destroyed in a chemical reaction. The total mass of reactants is equal to the total mass of the products. Okay, so what does it say? Law of conservation of mass says atoms can be created, can be created, can be destroyed, cannot be created or destroyed in a chemical reaction. There we go. They cannot be created or destroyed in a chemical reaction. Which of the following is true about chemical reactions? Atoms cannot be created in a chemical reaction. Well, that is definitely true there. Down the bottom here, atoms cannot be destroyed in a chemical reaction. That's true as well. There we go. We've gone blue. Next one. Here's a formula for working out the relative formula or relative molecular mass. So down here, this little symbol MR means to us the relative molecular, so the R is for relative, the M is for molecular mass of something, and what that little sign means there is just it's the sum of all the individual relative atomic masses. So the relative formula mass is equal to the sum of the relative atomic masses in the formula. Maybe we'll get one of those to do. Oh, there we go. The relative something mass is another name for the relative formula mass, so we're going to put in there the relative molecular mass is the right one. What do the symbols describe? So MR, remember, is R is the relative. The M in this case could be for molecular, or I'm going to put in here this time formula mass. Here we've got the R for relative again, but the A this time is for atomic. Okay, down the bottom here. So this is now having a little look at how to calculate the relative formula mass of something. So we're looking at a compound here, hydrochloric acid, that we're familiar with. We know the relative atomic mass of hydrogen is 1. The relative atomic mass of chlorine is 35.5. And therefore, HCl, hydrogen and chlorine, hydrochloric acid, is just 1 plus 35.5, which means 36.5 is the relative formula mass of hydrochloric acid. And we've got another one here, this time sulfuric acid, H2SO4. So we've just got to add up the individual relative atomic masses. Hydrogen's 1, sulfur's 32, oxygen's 16. But H2 means there's 2 hydrogens. So I've got 1 times 2, because there's 2 hydrogens. I've got sulfur, which is 32. Well, there's 1 of those, so 1 times 32. And if we look, oxygens, there's 4. So 16 is the relative atomic mass of oxygen. 4 times 16. Multiply them, then add them together, and we get 98 for that one.
Hi.
All right. Yeah. What are the steps when calculating the relative formula mass of a compound? So this is the things I need to do. Firstly, identify the relative atomic mass of each element, then multiply the relative atomic mass by the number of, I'm going to guess in there, that's going to be atoms in that one there. 2 seconds. So next bit, then we need to put how to calculate the relative formula mass in order. So the first thing I need to do is identify the relative atomic masses of each element in the compound. That's right. Then I need to multiply the relative atomic mass by the number of atoms. So I'm going to move that one up to there. And finally, add up the results for each element. Let's have a look. That's perfect. Right, the law of something of mass says that no atoms can be created or destroyed. Well, they're staying the same. They are being conserved. So it's the law of the conservation of mass. Okay, let's go down. We're almost at the end of this one, actually. So the average mass of an atom is the relative atomic mass, and the sum of all those relative atomic masses is the relative formula, or I could have put relative molecular mass there. So now we've got an example to try it here. What is the relative molecular mass of H2O? They're telling me that H is 1, and there's 2 of those, so 1 times 2 is 2, plus the O is 16, so 2 plus 16 is going to give me 18. And there I go, finished, 100%.